Hello, and welcome to the AI Research Roundup. I am your host, Alex. Today is May 26th, 2025. We're looking at a research paper from Hugging Face's trending list, published just 3 days ago, titled TabSTAR, a foundation tabular model with semantically target-aware representations. This paper addresses how deep learning traditionally underperforms on tabular data, where gradient-boosting decision trees, which are models that combine many simple decision pathways, usually dominate. TabSTAR proposes a new Tabular Foundation Model that better handles text in tables by using what the authors call semantically target-aware representations, helping the model understand text in relation to the prediction task. Alright, so this first figure gives us a nice visual of the TabSTAR architecture using a toy dataset. We see how it starts with verbalization, which means it converts all inputs, like age 40 to 50, free text from a report, and even potential decisions like released or hospitalized into a text format. Then, these are fed into separate numerical and textual encoders. The outputs are then fused together, passed through an interaction encoder, which is a type of transformer, and finally, to a prediction head to make the decision, such as hospitalized. Okay, so building on that architecture, this next table gives a concrete example of the verbalization process we touched on. We can see how different patient features are transformed. For example, an age of 45 is turned into the semantic text, age 40 to 50, quantile, 50 to 60%, where a quantile indicates its relative position within the data, and also into a standardized numerical z-score, which measures how far that age is from the average in terms of standard deviations. Similarly, text features like department and report are verbalized, and importantly, potential decision outcomes are also verbalized, like target, decision, hospitalized, which is key to making the model target-aware. Moving to the results, these bar charts compare TabSTAR's performance on classification tasks against other models. The scores are normalized, meaning they're adjusted to a common scale for fair comparison, and higher is better. On the left, for datasets with up to 10,000 examples, TabSTAR leads the pack. And on the right, for larger datasets above 10,000 examples, TabSTAR Unlimit really shines, significantly outperforming models like CatBoost and XGBoost. The little lines on the bars represent 95% confidence intervals, showing the range of likely true scores for each model. Alright, now this next figure really digs into a key design choice for TabSTAR. Specifically, how many layers of its text encoder should be unfrozen during pretraining? Remember, unfrozen means these layers can learn and adapt. On the left, we see validation loss, which is a measure of model error on a test dataset, plotted against training epochs or cycles. More unfrozen layers generally lead to lower, better validation loss. Then, the bar chart on the right shows normalized scores on later tasks. It clearly indicates that unfreezing 6 layers gives the best average score, significantly outperforming a completely frozen encoder. Building on the idea of optimizing the model during pre-training, this table looks at how the amount of pre-training data affects performance. We see normalized scores for both classification and regression tasks. As the number of pre-training datasets increases from 0 up to 256, the scores consistently go up. For classification, the score jumps from 0.352 to 0.786, and for regression, from 0.338 to 0.811. This clearly demonstrates that TabSTAR benefits from more pre-training data, showing a nice scaling effect. The plus-minus values represent those 95% confidence intervals. Okay, so we've seen that more pre-training data is beneficial. This next table then details the impact of different numerical verbalization methods. Remember, verbalization is about turning all features, including numbers, into a text format. We're looking at normalized scores for classification and regression. The methods compared are just using the feature's name, using the name plus binning, which groups numerical values into ranges, and then the full TabSTAR approach. For both types of tasks, TabSTAR's method, which incorporates richer semantic information like quantiles, clearly comes out on top, showing the advantage of its more sophisticated verbalization. So, TabSTAR's sophisticated numerical verbalization clearly makes a difference. In conclusion, TabSTAR truly advances handling tabular data with text, especially for classification. Its success uses an unfrozen text encoder and novel target-aware tokens for great generalization. We've seen it achieve high OROC scores, that's area under the receiver operating characteristic curve, a classification accuracy score, outperforming methods like gradient boosting decision trees, models that build many decision trees in sequence. It also fine-tunes efficiently with low-rank adaptation, or LoRA, which updates few model parameters. That's our roundup. I am Alex. Thanks for listening.